Good day, good people. In today's lesson, we continue with circle geometry, tichitaris tangents from an external point. But before we get into today's lesson, I just want us to have a quick revision of the work we did when we looked at tangents and radius. So chekutanga, we have our circle. Then a tangent is going to be a straight line which touches a circle on one particular point, which in our case is this point. Let us call it A. Then we have a center of this circle, O. Then a line which comes from the center, each no but a part of the circumference. In particularity, in this case, this point A is called a radius. So when we have a radius and a tangent connected by the same point A, the lines are going to be perpendicular, correct? They meet at 90 degrees. So ndechekutanga chatakaita. Then the second thing was, if we have the same situation like this, so this is the point, call it B, then we have our center O with a radius. Then from the center O toita imwe radius irikuya kunoku like this. Then tobatanidza these two lines like this. So this is a situation in wanzokuya. The first thing, whenever you have two radius are part of a circle, you have to know that radius are going to be of the same length. Saka kana radius are of the same length, automatically you have isosceles triangles. And when you have isosceles triangles, you have to know that my base angles are going to be equal. Saka like in a case we did yesterday, kana kubva pa point inoi here this line kunobata the tangent iri theta ka angle akaka zvoroti kange kari 90 minus theta, because we are subtracting theta from 90 yacho yabva kupi? Tirikuona kuti we have a radius iri kusangana neye tangent on a common point B. But if this is 90 minus theta, this is also going to be 90 minus theta, because these are base angles of an isosceles triangle. Isosceles triangle yagadzirwa nema radius ari 2 aya plus this chord. Then inoi yachanetsi kuwana, because it's simply 180 degrees subtracting, we can actually say subtracting 2 times 90 degrees minus theta. The way we do, kana tine situation where we are given two angles, but tirikutsvaga a missing angle, we use the sum of interior angles of a triangle. Kasaina kakankureva kuti summation, you are going to see it pamunenge magoita statistics in your advanced level. So the sum of interior angles of a triangle, we know that it's 180 degrees. Zvinobva kupi? Zvinobva paka formula kanaka kanoti the sum of angles inside any shape is going to be n minus 2 times 180 degrees. N yakamirira number of sides. Saka this in a nutshell summarizes what we did in our previous lesson. Let us now get to today's lesson. So we are having tangents, but they are from an external point. And we are going to exemplify zvatirkureva by this. But emphasis is on how important this is, because I have seen it make an appearance in many tests. What is going to be the theorem? So to us, this is going to be theorem number 6. So after theorem number 6, tichajamba conduct of circles, because circle geometry usually painotestewa inoshandiswa kutsvaga missing angles. sometimes we might be tasked kutsvaga a missing side, but it would be obvious, like just a basic application of Pythagoras theorem, or it can be a little complicated, like applying sine rule or cosine rule or trig ratios chasho tau. But conduct of circles, it's a little out of scope kana tichitarisa circle geometry, so we are going to skip over it tichienda kualternate segments. But if you think it necessary kuti tiite conduct of circles, you can always tell us in our comments, and we will do it. We will attend to that part of our topic. Okay, zviri kunzi, the tangents to a circle from an external point are equal. Tangents and to a circle from an external point are equal. We are not going to bother ourselves with the proof, but let us just exemplify zviri kurehwa. We have a circle with a center, then two radius, imwe rikunobata A, imwe rikunobata B, then radius aya toma connector like this. Then we have a straight line. Before we can do that, we have a tangent iri kunobata A, toita futi another tangent iri kunobata B, and zviri kusangana pa this common point T. Then we have a line rakadai so. So this is what we have. Zvatataurirwa this theorem zvanzi the tangents to a circle from an external point. So T inoi ndo inenge chinzi chi external point. Taona kuti T ndo inenge iri external point. Matangents edu ndi AT na BT. Ndo ari kunzi tangents to a circle from an external point are equal. So this is going to be equal to that. But before we go anywhere, I want you to notice that shape is actually a kite. Tikaibuditsa panze like this, you are going to see that this is a kite. So apa pana A, apa pana B, pana T. Then we have this diagonal line and that diagonal line again. So the properties of a kite which are going to be material to us, the aya, we should know that pana x nasina kusa x, tofunga kusiwa kuti ax na xb are equal to each other. Saka tatoudzwa netheorem kuti this is going to be equal to this, and you should also know kuti this is equal to this. Saka ngandise 3 panapa kuti zvisiyane. So let us write it down. OA iri equal to OB and AT iri equal to BT. Saka yama properties echi a kite. Then you should know kuti angle iri panapa inenge iri equal to angle iri pano. And as you can see from our example here, angle iri pana A, it's 90. Why is it 90? Because this is a radius irikusangana ne tangent. Angle iri pana B, it's also 90. Saka the angle iri pana A iri equal to angle iri pana B, which is equal to 90 degrees. Then angle iri panapa ne angle iri apa, they are supplementary. Kureva kuti angle iri pana O mukati plus angle iri pana T tikazvieda zvofunga kuti pa 180 degrees. So ndo ma properties a kite atinofanirwa kuapply panapa. Angle iri pa A neiri pa B, they are equal to each other. Technically kana tichizvitaura tinoti angle inogadzirwa ne two unequal lines the angles which are made by two unequal lines are going to be equal to each other. Then opposite angles are supplementary. Then the other thing is this diagonal bisects line AB. So these are properties of a kite which we should know. Let us go to example 3a. That's the first question we want to deal with. X, Y, Z are 3 points on a circle, center O. The tangents at X and Y meet at T. If XTY is equals to 58 degrees, calculate X, Z, Y. So this is the diagram we have, and let us see what is Rufamba saying. So we have a circle, we have 2 points X, Y, like this. Then we have two tangents ari kusangana pa point T. Taudzwa panapa kuti it's 58 degrees, and then we have a point Z iri kunoko, like that. Saka kite redu ragadzirwa like that, but we have a center O. Tikadzokera question iri kuti X, Y, Z are 3 points on a circle. Saka X, Y, Z with center O. The tangent at X and Y meet at T, and if XTY is equals to 58 degrees, calculate VXY. Kuroti angle yatiri kuda nde ino-ish. But kana T nayo yakaita sezva yakaita, like the way we look at it like that, what can we do? Firstly, we acknowledge kuti this line is equal to this line up until this point. Saka xt is equal to yt. Then we can cite a reason kuti they are tangents from external point. So tangents from external point. That is the reason why they are equal. Then taona kuti they are equal because of that. What we can do here, kuti tigadzire kite, and because tudagadzira ka small kite, what we can do is we can join X to the center and also Y to the center. But as you can see panapa tofanga kubuditsa ka triangle. Saka position ya X yangu yaita kuti zisanyatso kubuda, but we can just adjust that. Saka ngatiti O ari panapa kuti ka triangle kedu kaiteka kubuda shoma. Yeah, like that. Saka kana triangle yedu yabuda, and despite saying triangle, kana ta joina X to O, Y to O, saka O wedu sorewa kuti tavane kite. And the kite inotudza kuti kudini? Kite inotudza kuti opposite sides, what are they? Opposite sides are going to be supplementary. Saka angle ish OXY, and it inenge equal to chi. Tikati OXY plus 58 degrees. Zofunga kuti pachi 180 degrees. Reason opposite sides of a kite are supplementary. That's the reason. Kana kuti add up to 180. Kana kuti add up to 180. You can pick your poison. Saka OXY inge equal to 180 degrees subtracting 58 degrees. What do we get? This is equal to 122 degrees. Taona kuti panapa it's 122 degrees. Then we should know kuti angle yatiri kutsvaga XZY inenge iri equal to half ye angle iri pakati apa XOY. And what is the reason? if you remember our first theorem yataura ichiti angle at center is twice angle at circumference. That's the reason. Theorem number 1. So theorem number 1 yakabata zvakawanda. So kana zvadai so manje zvoreva kuti this is going to be equal to half of chi 122. What is it? 2 into 2 1 into 12 into 6 into 2 into the 1 61 degrees. So the answer is 61 degrees, as you can evidently see panapa 61 degrees. So this one is 61 degrees. Ndio yatanga tanzi titsvage here. Question yati calculate xzy. Xzy it's 61 degrees. Ndio yava one apa. But if we read this small conclusion, it could if z is on the minor arc xy at z, then xzy is equals to 119 degrees, opposite angles of cyclic quad. Hence xyz is 61 degrees or 119 degrees. What are they talking about? So takalculate tikaona kuti xyz is equal to 61 degrees, but they are making a further conclusion kuti if z is on the minor arc xy and then xzy is equals to 119, opposite angles of cyclic quadrilaterals. Hence no, don't go further like that, because musiyano waikaita working yavo neyangu ndeyekuti ina handina kuzowedzera maline aya. This is too much circumspective, and because vo vari kuti angle e blah blah blah, it's too much circumspective. Saka ende paniki paiswa vaibva vaisa kazeti 1 panapa, too much circumspective. So follow what I have done. Let me explain my method. Chekutanga taona kuti tapiwa tangents ari external to the model, kureva kuti ari kubva from an external point which is t. The first thing we do is we have to make up a kite, because we want to use properties of a kite. But to make up a kite, we have to join certain lines to the center, which is O. Saka taisa ma broken lines tikajoina x kuna O, y kuna O, tikava ne kite. Then we know from what we learned about the kite, kuti opposite angles are going to be supplementary, or they add up to 180 degrees. Saka we can use that to calculate. Knowing kuti panapa is 58 degrees, we can calculate this angle 122 degrees. Then also apply the first theorem, not angle at the center is twice angle at the circumference. Saka z cannot xzy inenge equal to 61 degrees. So that is the answer. Kwavari kuenda mberi ne solution yavo, they are now using a lot of circumspective statements. So you don't expect to find an answer which is going to have 2 true values. It's only 1 true value. So leave it there. But what is important is make up a kite. Make up a kite and know the properties of a kite. So let me just quickly repeat the properties of a kite. Indo kite like this. Saka we have this diagonal toita this diagonal. Iri line iri rinodambura diagonal into 2 halves. Saka kana panapa paina tongoti pakati apa pana x, apa pana a, apa pana b, c, d. Ax inenge iri equal to ab. They are equal in length because zvadamburwa nechi the diagonal cd. The other thing is angle iri pana a panapa inenge iri equal to angle iri pana b. And in terms of now we are to kudila nayo ku circle GUI, kana kuri kuti panapa C uyu isenda zvoreva kuti inge iri equal to 90 degrees. Saka it's only equal to 90 degrees if it is in the context of circle geometry. Kana tichita circle geo, because panenge pachisangana radius netangent, saka inge iri 90 degrees. But if you are just doing my kite somewhere, it's not obvious what it's 90 degrees. Then angle iri pana C neiri pana D, tikazviedha zvofanirwa kutipa 180 degrees. Saka ndo maproperties ari 3 amunofanirwa kuziva a kite. Okay, let us look at our exercise and see what we can do. Saka ma questions e circle geometry asina kuiswa a diagram. I usually assign them as your homework. So one yakakosha because iri kutiita refer back to fig 3.12 to answer the following. Saka you have to refer back to fig 3.12, which is iri kumusoro I bet this one, and answer the following questions. So that's your homework. We want to find if we have any questions to discuss here. And then number 2 musaita yekuprova if it's a cyclic quadrilateral. My questions yekuprova, they are advanced level in most cases, especially when it relates to things like circle geo. Then what about number 3? I want you to do foot number 4. Then 5. It's easy. Pama questions esatakupai as homework, I want you to make this top priority. Saka, this is more going to be a research question. If you have done your research and tried to solve it, you can come back with your answer, and if you need assistance, I will be there to assist. The reason why I have made that top priority, it's because as we can see, matangents edu has to connect directly to the sender. We do not have a kite. We can only have a kite if we had connected O to C like this. That is the only time we would be having a kite. We would have made this 90 and also this 90. Taudzwa panapa, if we read the question in fig 3.14, AB is the diameter of a circle ABC, center O, TA and TC are tangents. If ATC is equal to 2x, show that BAC is equal to x. Saka tikajoin apa, panapa, pana 2x. The other thing which I hadn't shown you, pama properties of a kite is this. Saka, my properties are tighter, that we have 2 diagonal lines, but diagonal line iri wombe rinoita kuti this line, this half is equal to this half. Tikati this angle is equal to this angle, but angle E ne iyo tikadzeda dzinoti pa 180. The other thing is, line repakati rinonzi bisector. A bisector I line rinohafura in angle. Saka kapiske angle akaka kani kari equal to kapiska naka. Kapisa aka kari equal to aka. Saka kana taudzwa panapa kuti ATC, which is ATC equal to 2x. So kuti panapa ndi x, apa futi ndiani ndi x. That is very important. Saka kana zvakadaro zvoreva kuti panapa inge iri 180 minus 2x. And of course panapa it's 90, apo futi it's 90. Like that. Chatiri kuda kutsvaga isusu ka small part kanaka kuti kange kari chi. So we have to devise methods of doing that. But we should also appreciate that since OC iri radius, OA iri radius, so that this radius are two and are equal to each other, making base angles equal. Kureva kuti tikawana ka part kanaka, tinenge tatowana part yatiri kutsvaga. That's also another way of looking at it. So I'm just giving you some hints and stuff so that when you try to solve this question, you will have some form of guardianship. Otherwise, this concludes materially and naturally what we wanted to look at when it comes to tangents from an exterior point. In our next lesson, hatisi kuzoita conduct of circles as I explained earlier. We are going to then do alternate segments. And taita alternate segments, tinenge tapedza our topic. Sine rule iyi kana muchida, we have a cluster on trigonometry where you can find it. My last word is, I want to come with some form of appreciation. As you can see on your screen, we now have 12,000 views on our channel Tapiwa Kurotu the Second Nyemba. It might appear to be a small number, but it is really great to me because it means 12,000 times people were watching the videos we were creating. And I hope one day someone will stand up and say, it is because of the tutorial videos I watched from this channel that I was able to finally or eventually pass O-level mathematics and other subjects which we are going to bring. So thank you for your support. Thank you to those who are subscribing. To those who haven't, you are welcome to join the family. Thank you to those who are liking. Thank you to those who are sharing to your friends and family. And most importantly, thanks to those who are commenting. I'm enjoying the conversations, even though I would encourage us to engage more on the material part of things. Are you understanding the material? Do you have any questions pertaining to the material? And also just engage in conversation. So that is what I wanted to thank you for before we conclude this particular lesson. Then the last thing would be, kune vanoda ma-extra lessons, vanoda extra help. My videos atinoisa pa YouTube, of course, they are not priced. Correct, it's for free. It's free help. It's a quid pro quo relationship if you want to think about it. But it's free stuff. But if you want assistance, correct, a step above what we are offering here, you can WhatsApp us on these two numbers. So as we all know, the +263 is the Zimbabwean code. We also have a South African number which goes like this. And these numbers, they are only WhatsApp. Of course, you can call, but if you enjoy calling, you use this one for now. But I would much more prefer WhatsApp. Then we can discuss how we can help each other further. My last word is good luck. I wouldn't call it luck, but you need a little luck to those who are writing their ZIMSEC 2025, 13 October and 15 October. I'm rushing against the time to finish a few topics which I haven't done so that you have a fighting chance to pass. Thank you and have a nice day.